Alright, I'm going to talk about solving radical equations. This is the same thing as solving equations with rational exponents, okay? So even though that just says radical equations, this is the same thing as solving equations with rational exponents. We've understood, or should have understood, that rational exponents and radical equations, or radicals, are the same. Now, here's our goal, and we need to define inverse, a process that allows you to go back or undo an operation. So that's very important. Big hint. The inverse of x squared is to take the square root. Alright? The inverse of the square root is to raise to the second power, or to square it. Now, we're not only going to be dealing with square roots, but this is just a hint for us to kind of just think about the inverse idea. And so I want you to understand that we've been using inverses. And so look at these three examples here. If I ask you to solve for x here, you would use an inverse. For example, if we look at number 1, in order for me to solve this, I have to add 6 to both sides. That's actually the inverse of subtraction, is addition. Okay? And so that gives you 10. We've been using inverses. I just said the inverse of x squared is to take the square root. So in order for me to solve this, I have to actually take the square root. And that's really plus or minus 2 there. See, we've been using inverses all along. Alright, so it's no different. The inverse of division right here. This is division. The inverse of division is to multiply. And so I want you to understand that this is no new concept today. It's something that we've been doing over and over and over, and that is using inverses to undo or to go back, so to speak. And so we need to go back when our problems look like this. And so how do we do that? Remember, this is our goal. We need to isolate the radical. That means move everything away. There should be nothing added or subtracted or multiplied or anything on the same side as your radical. Raise both sides of the equation to the index. I'm going to use square root a lot in these problems, but please understand it's the same thing for a cubed root or a fourth root or whatever. Simplify and solve and check your answers, okay? We have to check our answers here. So notice my instructions say solve and check. They won't always say check. You need to know how to do that. You need to remember to do that. So let's go ahead and look at these examples here. Alright. I need to solve for x. But in order to do that, I have to make sure that my radical is isolated. Notice the 2 that's right next to the radical. That means multiply. You need to make sure you understand that. You can't subtract that 2 away. So I do the inverse of multiplication, which is division. Those cancel out. And I'm left with the square root of x plus 1 equals 7. Alright? Now that I have this right here, remember this is a square root. I said raise each side to your index. The index is a 2, so I'm going to raise each side to a 2. And so right here, what happens is the x plus 1 drops out, and this is not 7 times 2. This is 7 squared, or 7 times 7. And you get 49. Now I solve by subtracting 1 from both sides, and I get 48. Now that's solved, but let's check it. If I do 48 plus 1, that's 49. The square root of 49 is 7. 2 times 7 is 14, so that works out. I don't get a negative number underneath the radical, so 48 is cool. Alright? Now just real quick, I want to show you that at this stage I could have had x plus 1 raised to the 1/2 equals 7. Please understand that these two problems are exactly the same thing. Okay? The square root and x plus 1 quantity quantity raised to the 1/2 is the same as this. And so the way I would solve it is the same idea, is raise both sides to the second power. Alright? Now, let's move on to our next example. Alright, the next problem is number 5 here. And remember, the first objective, if you look at those steps, hopefully you wrote them down, is to make sure your radical is isolated, meaning there can't be nothing added, subtracted, multiplied, or divided to your radical. So therefore, this 5 is right next to the radical. I understand that means multiply, so my first objective is to divide this 5 to both sides. Now, I get the square root of x plus 2 once I do that, and over here I get 7x. Notice I have variables on both sides. It does not matter, because the next thing I have to do is remove this square root, or this radical. What's the index again? 2. The index is 2, so therefore that's what I use to raise both sides to. And so this becomes x plus 2, and this over here becomes 49x squared. Both of those gets raised to the second power. Okay, not just the 7, but the 7 and x. Now, what happens here? Well, this now becomes a quadratic equation, and so the way I solve this is different from the last problem. So oftentimes whenever you work these problems, what will happen is the way you're going to solve it depends on what's actually in the problem. 49x squared minus x minus 2 is what that turns out to be. For the sake of time, I went ahead and worked this one out just because it's going to take a while. Turns out that this doesn't factor, and so what I went ahead and did was the quadratic formula. Since it's a quadratic equation, we have factoring, we have complete the square, we have quadratic formula and square roots, and the one I chose is quadratic formula. You can look over my work. If you don't remember, go review the notes for quadratic formula or solving quadratic equations, and you get these two solutions here, approximate solutions here. Hopefully we won't have many of these. I did these notes years ago, and so I probably should have changed that into a better problem. But let's continue moving on to our last example here. Our last example is this particular problem right here. So let's work this one. Okay, so here we go. Remember, nothing should be added, subtracted, multiplied to your variable, even to your radical even variables. So the first thing I'm going to do is add x to both sides. Alright? So what does that leave me? The square root of x plus 18 equals x minus 2. That's how you want to write that. Index is 2, so I raise both sides to the second power. Over here I have x plus 18. The bottom basically opens and they drop down. Over here I have a FOIL. This is x squared minus 4x plus 4. Now, understand, what this is really x minus 2 times x minus 2. And when you do the FOIL, you'll get that. I know, I've already done it. So now, whenever you have a quadratic equation, remember, for the most part, everything needs to be on the same side. So I subtract 18 and x, at one time. So it equals 0. I got x squared minus 5x minus 14. And now let's see if this will factor. Okay? If it does factor, why, by the way? Because this is how you solve. Factor, quadratic formula. Yes, I can use quadratic formula or completing the square or something like that. The factors of 14 are 1 and 14, 2 and 7. I can get a negative 5 if I make the 7 negative by addition and subtraction. Since my leading coefficient is 1, that's all I have to do. And I say x plus 2 and x minus 7. And then you take each one of those and set them equal to 0. And you'll get x equals negative 2 by subtraction and x equals 7 by addition. Now before I circle those, I need to check my answers. Remember, you have to check your answers. So if I put negative 2 in here, I'll get 16. The square root of 16 is 4. So 4 minus a negative 2, that means 4 plus 2. Okay, let's not do that in our head so I don't get confused. Negative 2 plus 18 minus a negative 2 equals negative 2. Alright, so this is 4. The square root of 16 is 4 plus 2 equals negative 2. Yay. So, just got interrupted. But this becomes 4 plus 2, which is 6, and 6 does not equal negative 2. However, over here, when I put my other solution, 7 in, 7 plus 18 is 25. The square root of 25 is 5. 5 minus 7 does equal negative 2. So my only solution here is actually 7. So guys, this is where you need to make sure you check your answers. Make sure to check your answers. All of the answers are not necessarily answers. I think back in the day they used to call them erroneous solutions or something else. Alright, let's try to quickly run through what about if we have two radicals. If you got two radicals, you want to see if you can get one on each side. So the first thing I do is I take my negative radical and I'm adding it to both sides of my equation. Therefore, my equation is really going to be the square root of 2x minus 15 equals the square root of x plus 5. And once you get to the stage, you'll realize that it's really not that challenging at all, because now I raise both sides to the second power. And what happens is 2x minus 15 and x plus 5 drops out, and you have a very simple Algebra 1 type of problem. Okay, very simple. The magic of film, we can go ahead and solve that really quickly. I just want to get through as many examples of different types of problems as I can. See, notice there's a little difference here. First, my radicals are gone and I have rational exponents. Remember, these mean the same thing. But the way I'm going to approach this problem is pretty much the same way. I say pretty much because I have to really consider. The idea is always to raise each side to where your exponent is going to be a 1. And so the actual inverse of this would be to raise each side to the reciprocal of my fraction here. If I raise each side to the 2/3, what will happen is over here I'll get x to the 6 over 6, right? Because you multiply. But 6 over 6 really is just x to the first power. Alright? So that's very important. And over here I got the cubed root of 27 squared. Easy. So that equals 9. Put it in your calculator if you don't believe me. And that's how you would solve these problems. Very simple. The same thing goes for this particular example here. Instead of just raising it to the 4th power like we were doing, because that would be the index, when you have a numerator that's other than 1, you need to raise them to your reciprocal of your exponent. Alright? So that's how you solve these. The reciprocal of 3/4 is 4 over 3, and you get m equals the cubed root of 27 to the 4th power. And so m would equal 81. Again, just different types of examples on how you would work some of these. Remember, you have to take stock in what your problem looks like at the beginning to make sure that you know which step to use. Notice you're not always going to raise just to the index like you have on some of these other problems. You will have to use a reciprocal every so often. And it's not whenever you see fractional exponents, it's whenever the numerator is not 1. If it was 1/2, I just would have raised to 2. If it was 1/4, I just would have raised to the 4th power. But since it was 3 over 2, my numerator was not 1, I had to use the reciprocal. Since it was 3 over 4, I had to use 4 over 3, the reciprocal. Alright, let's look at this example here, where I have rational exponents. I don't have a radical again, but notice that it's being raised to the 1/4 power. I still use the reciprocal here, but the reciprocal of 1/4 is actually just 4. So I'm going to raise both sides of this to the 4th power. Why? Because that's the reciprocal of 1 over 4. So I'm still using reciprocal. Just like I did on these problems here, I'm still using the reciprocal. So if you want to do that, that's perfectly fine. And you get 2x plus 27, because that's what happens there. Those equal 1, and this just drops out. And now you have 3 to the 4th power, which is 81. Simple equation that you can solve for. Alright, so after working the problem, kind of jumped around. After working the problem, you get 27. Alright, so I want you to understand, rational exponents, you multiply or raise each side to the reciprocal of your exponent. And I showed several examples of that. Now, I just want to review real quick the steps. Here you go. Isolate the radical. If there's 2 radicals, you want 1 radical on each side. Sometimes, depending on how far we go, you'll have 3 radicals, and then you can't eliminate 1 on each side. But 1 radical, isolate everything. No adding or subtracting or anything to that radical on any side. And then follow the rest of these procedures here. Alrighty.